Hey guys, so today's episode is going to be on ratios and rates, which we started talking about last week, but I just wanted to clarify a couple of things. So in this episode, you will learn different ways to represent ratios, how to write and solve a ratio, how to find a unit rate, and how to convert between different units of measurement. So first off, what is a ratio? A ratio is a comparison of two quantities. So we can write a ratio in three different ways. The first way is with the word to, so a 3-to-2 ratio. The second way we can write it is using a colon. So we can place a colon between the numerator and the denominator. So in this example, we have 3 and 2. So you can also say it as a 3-to-2 ratio. And then the last way is the way we most commonly see a ratio, which is as a fraction, so 3/2. So an equivalent ratio is a ratio where the two quantities are the same. So for example, 3/2 is equal to 30/20 because we simply scale up by 10, sorry. So we'll talk tomorrow about how to compare ratios, which means we'll figure out how to tell if two ratios or two fractions are equal. So when we are writing a ratio, I have an example below here. So it says an archer shoots 60 arrows at a target, with 44 arrows hitting the target and 16 missing it. So if we want to write a ratio of the number of hits to the number of misses, the number of hits needs to be in our numerator because it is the first quantity that we see. So it's the part that's before the word to. So number of hits is our numerator, and our denominator is the number of misses because it's after the word to. So our numerator will be 44 because that's how many hit the target, and our denominator is 16 because that's how many missed. So we could simplify by scaling down by 4 to make a fraction of 11/4. So now I want us to think about, would it make sense to write this ratio as a mixed number? So would it make sense to change 11/4 to a mixed number to represent the ratio of hits to misses? So since 11/4 is equal to 2 3/4, let's see if this makes sense when we're thinking about number of hits to number of misses. We can write 2 3/4 as a ratio of 2 3/4 over 1, right? So 2 3/4 over 1, we don't have to write it that way because dividing by 1 just means we'll get 2 3/4 because we wrote this as the number of hits over the number of misses. So that means that for every one miss, which is our denominator, there are 2 3/4 hits. So this is kind of very close to a 1-to-3 ratio, meaning that every time someone missed, they would then hit the target 3 times. So we can write the ratio as a mixed number, even though maybe with a improper fraction it might be a little bit easier to see the comparison, but we can still write it as a mixed number. So thinking about this same problem, if we wanted to write a ratio of the number of hits to the number of shots, now we're going to have a different ratio. So since number of hits is before the word to, that will be our numerator, and the number of shots will be our denominator because it's after the word to. So this is kind of using words. So number of hits to the number of shots. So since there's still 44 hits, now there are 60 shots or 60 attempts. We could simplify that to 11/15 by scaling down by 4. So unit rate. A unit rate is a rate that has a denominator or numerator of 1 when in fraction form. Unit rates are often indicated by the word per, which means for every. So you might see a word problem that has the word per in it. That kind of tells you, okay, maybe we need to find the unit rate for something. So the example is one that we had done in class earlier, but I kind of wanted to show two different ways we could think about this. So it says, you host a party for 12 people. The food and drinks for the party cost $66. What is the cost per person? So when I think about this, I think the cost per person, I want to figure out the cost for one person. So that means that the cost for one person I know is going to be less than 66. So that kind of tells me that I know that I'm going to be scaling down by something. So there's two ways we can think about this. We can think about the numerator is the number of people, and the denominator is the total cost, or we could think about the total cost is our numerator, and our denominator is number of people. Since it doesn't indicate in this problem which one needs to be on top, because I don't see the word 2 anywhere, we can kind of pick and choose. So what I chose is that I chose to put the number of people on top. So I have a ratio of 12 people to $66. So if I want the cost for one person, I now know that I need to scale down by 12, right? Because 12 divided by 12 is 1. So if I do 12 divided by 12 to get 1, I also need to divide 66 by 12. So 66 divided by 12 is $5.50. So the cost per person is $5.50. If I chose to put the total cost on top and the number of people as my denominator, I would still get the same thing because I'd still be doing 66 divided by 12. It just would be on the numerator instead of the denominator. So we would get the same thing. So my second example is Evan purchased 24 muffins for $15 to sell at a bake sale. What is the cost per muffin? So if I think about this, I want the cost of one muffin. So if 24 costs 15, I know it's going to be less than $15, so I know that I'll be scaling down. So I can think about my ratio of 24 to 15 with number of muffins on top and cost on bottom. But we could also flip it and have the cost on top and the number of muffins on the bottom. So if I want the cost per muffin, I set up my ratio of 24 over 15 equals 1 over x. Then I realize that I'm dividing by 24. So 15 divided by 24 can be simplified to 5/8, which would be 0.625. I can get that by either scaling up to 1,000 or simply just dividing. So since we need an amount of money, that's not really an amount of money, because if we want money, we need the hundredths place only. So we would round up to 0.63, because the 5 tells me in the thousandths place tells me I need to move up a place. So each muffin cost about 63 cents. Okay, lastly, when we want to use ratios to compare units of measurement, for example, going from feet to inches, from centimeters to meters, we need to use a ratio. So in this example, it says, suppose you made $33,000 per year. How much would you make per month? Set up a ratio to solve. So if I want to set up a ratio, I know that I make $33,000 per year. So in 1 year, I make $33,000. So I'm going to choose to put my money on top and the length of time on the bottom. So I set up a ratio of 33,000 over 1 year equal to X dollars per month. Now the problem is we can't really compare year to month until we figure out how many months are in a year. So since there's 12 months in a year, I can write my ratio like this. $33,000 per 12 months equals X dollars over 1 month. So now I can see that I need to scale down by what? 12. So since I do 12 divided by 12 to get 1 month, I can do 33,000 divided by 12, which is 2,750. So that means that you would make $2,750 per month. Last one. A fighter jet travels 300 miles in 20 seconds. How many miles does it travel in 1 minute? So if I want to set up a ratio, I'm going to use 300 miles in my numerator and the time in my denominator. But you can switch it and do either way. That's the bell. So 3,000 miles equals over 20 seconds is equal to X miles over 1 minute. I need to figure out my conversion from seconds to minutes or minutes to seconds. Since there's 60 seconds in a minute, I can write my ratio like this. 300 miles per 20 seconds equals X miles over 60 seconds. So now I realize that I'm going to be scaling up from 20 to 60 by multiplying by 3. So then I can do 300 times 3 to get 900 miles. So the fighter jet travels 900 miles in 60 seconds, or in 1 minute. Okay, thanks for watching. See y'all tomorrow.